Good evening to all. Myself, Dr. Himani West, Assistant Professor in Chemistry in Government Degree College, Satpuri, Pauri, Garhwal, Uttarakhand. In this video lecture, I will discuss about isomerism in organic compounds. Isomers are the compounds with the same qualitative and quantitative composition of elements. Therefore, their relative molecular weight and general formulas are identical, but their structures, such as sequence of bonding and or arrangement of the atoms or groups in the space, are different. This variation of the structure, that is different structure formulas or three-dimensional arrangement of atoms, can lead to possessing different physical and chemical properties. And hence these compounds behave as different compounds with the same molecular formula. So isomerism defined as two or more compounds having the same molecular formula but different chemical and physical properties are called isomers, and the phenomenon is known as isomerism. From the Greek word isos meaning equal and meros meaning part, concept and term introduced by the Swedish scientist Jacob Berzelius in 1830. The isomerism in organic compounds can be classified broadly into structural isomerism and stereoisomerism, which can be further categorized into different subtypes. And this flowchart shows the different isomer categories. The structural isomerism is also called as constitutional isomerism, is one in which two or more organic compounds having the same molecular formula but different structures. The functional groups and the atom in the molecules of the isomer are linked in different ways and sequence. Different structural isomers are assigned different IPAC name. The structural isomers usually show different physical and chemical properties. And stereoisomerism is a form of isomerism in which molecules have the same molecular formula and same constitution but differ in three-dimensional orientation of their atom in space. The structural isomerism is further divided into chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, and ring chain isomerism. And stereoisomerism is divided into geometrical isomerism and optical isomerism. In structure isomerism, first is chain isomerism. Two or more compounds which have a similar molecular formula but different arrangement of carbon atoms leading to linear branch chain are referred to as chain isomers, and they have almost similar chemical property but different physical properties. For example, two chain isomer possible with the molecular formula C4H10 and butane, a linear chain isomer, and isobutane, a branch chain isomer. And three isomers are possible with the molecular formula C5H12 and pentane, a linear chain isomer, and isopentane and neopentane are branch chain isomer. Generally, branch chain isomers have lower boiling and melting point than their linear chain isomers. The boiling and melting point of isobutane are minus 12 degrees Celsius and minus 160 degrees Celsius, respectively, compared with the boiling point of N-butane 0 degrees Celsius and melting point minus 138 degrees Celsius. And the boiling point of N-pentane is 36 degrees Celsius, and for isopentane is 28 degrees Celsius, and neopentane 10 degrees Celsius. This is because the linear chain isomer have more surface area of contact, and hence they have a strong intermolecular force of attraction in the molecule, which compared to the branch chain isomer, which have a compact phase. And second is positional isomerism. Two or more compounds with the same molecular formula, but differ in position of side chain, subsequent atom, functional group, double bond, triple bond, etc. on the parent chain are known as positional isomers, and the phenomena is termed as positional isomerism. Those isomers have similar chemical property but slightly different physical property. For example, 1-chloropropane and 2-chloropropane are the positional isomers with the molecular formula C3S7Cl. These isomers arises due to difference in the chloro group on the main chain. 1-chloropropane is straight chain isomer, has higher boiling point, whereas 2-chloropropane has branching in it, so it has lower boiling point. Similarly, 1-propanol and 2-propanol are Positional isomer with the molecular formula C3H8O. The functional group OH is at different position on the main chain. One propanol, which is straight chain isomer, has a higher boiling point than two propanol. Similarly, 1-butene and 2-butene are positional isomer with the molecular formula C4H8. These isomers arises due to difference in the position of double bond on the main chain. Third is functional isomerism. Functional group isomerism is shown by the isomers which have the same molecular formula but contain different functional groups. The functional group isomers shows different physical as well as chemical properties. The dimethyl ether is a functional isomer of ethyl alcohol. Both have the same molecular formula C2S6O. However, they have different functional groups. Dimethyl ether is a gas and ethanol on the other hand is a liquid at room temperature. And the boiling point of ethanol is much higher than ether. The dominant intermolecular attraction between ethanol molecule is hydrogen bonding. On the other hand, in dimethyl ether has dipole-dipole interaction. Because hydrogen bonds are typically much stronger intermolecular force than dipole-dipole interaction. Due to strong intermolecular force of attraction in ethanol molecule than dimethyl ether molecule, ethanol has higher boiling point. And propanone and propanol are functional group isomer with the molecular formula C3S6O. Both propanone and propanol has dipole-dipole interaction between the molecules, and propanone has slightly higher boiling point as a result of higher dipole moment than propanol. And in both isomer, functional group are different, and propanol is a aldehyde and it reduces Tollens reagent and failing solution, but propanone being a ketone does not. And propanone being a methyl ketone respond to iodoform test, but propanol does not. And next is metamerism isomerism. Metamerism isomerism is defined as two or more compounds with the same molecular formula and same functional group, but different alkyl group on either side of the polyvalent functional group, like ketone, ether, ester, etc. in the molecule. Three isomers are possible with the molecular formula C4H10O, having ether as a functional group. These isomers have both London dispersion forces and dipole-dipole interaction. Because of the polar oxygen bond, so have higher boiling point than the non-polar molecules like alkanes. There is slightly difference in the boiling point of these three isomers. The branch chain isomer, that is isopropyl methyl ether, have lower boiling point than their linear chain isomer due to decrease in the intermolecular force of attraction in the molecule. And two isomers are possible with the molecular formula C5H10O, 2-pentanone and 3-pentanone. And the boiling point of these two isomers are almost same, but chemical properties are different. 2-pentanone being a methyl ketone give positive iodoform test, but 3-pentanone does not give. Next is tautomerism. Tautomerism is a dynamic equilibrium between two compounds with the same molecular formula, but differ only in the position of protons and electrons. The carbon skeleton of the compound is unchanged, but functional groups are different. This reaction involves simple proton transfer in an intramolecular fashion. An important example of the phenomenon is keto-enol tautomerism. Keto-enol tautomerism refers to a chemical equilibrium between the keto form, the carbonate structure containing alpha hydrogen, and the enol form, a double bond adjacent to alcohol of a compound. The enol and keto form are said to be tautomers of each other. It is compressive process that is acid or base catalyzed. The keto form of the compound is more thermodynamically stable and highly favored. And acetone shows the keto-enol tautomerism. Acetone exists in rapid equilibrium with a tautomeric form known as enol, and acetone exists in 99.999% in keto tautomer and only 0.001% in enol tautomer. Both have different chemical properties. Keto form is electrophilic in nature and react with nucleophile at carbonyl carbon, whereas enol form is nucleophilic and react with electrophile at alpha carbon. Ethyl acetoacetate adjusts as a tautomeric mixture of keto and enol form. Ethyl acetoacetate contain two functional groups. One is ketone and the other is ester. Those two functional groups are separated by a methylene group. Those methylene hydrogens are highly acidic in nature. They are loosely bound to the molecule, and those methylene hydrogen are moved toward those functional groups and activate an isomerism. It's called ketoenol tautomerism. Ethyl acetoacetate exists in 90% in keto form and only 10% in enol form. And the last is ring isomerism. In ring isomerism, one of the isomer has open chain structure, whereas the other has a ring structure. Propene and cyclopropene are ring chain isomer with the molecular formula C3S8. And similarly, C3S8. Similarly, butene, cyclobutene, and methyl cyclopropane are ring chain isomer with the molecular formula C4H8. And next is stereoisomerism. Stereoisomerism, the isomer having the same molecular formula, same chemical constitution, and the same chemical properties, physical properties, but different spatial arrangement of their atoms. And there are two types. The first is enantiomer, and the second is diastereomer. Enantiomer, also known as optical isomer, and are two stereoisomers that are related to each other by a reflection. They are mirror image of each other that are non-superimposable. Two compounds that are enantiomer of each other have same chemical and physical properties except for the direction in which they rotate plane polarized light. And diastereomers are stereoisomers not related through a reflection operation. They are not mirror image of each other. And these include cis-trans isomers, EZ isomers, and meso compound, and non-enantiomeric optical isomers. Diastereomers seldom have the same physical properties. Next is geometrical isomerism. An isomerism which arises due to restricted rotation about a bond in a molecule is known as geometrical or cis-trans isomerism. The carbon atom of the carbon-carbon double bond are sp2 hybridized. The carbon-carbon double bond consists of a sigma bond and one pi bond, and the sigma bond is formed by the overlap of sp2 hybrid orbital. The pi bond locks the molecule in one position. The two carbon of the C double bond C bond and the four atoms that are attached to them lie in the one plane, and their position in space are fixed. This restriction of rotation about the carbon-carbon double bond is responsible for the geometrical isomerism in alkene. 2-butene, for example, 2-butene, it exists in two spatial arrangement, that is cis-2-butene and trans-2-butene. In the cis isomer, the two methyl groups are arranged on the same side of a double bond, whereas in the trans isomer, they are on the opposite side. The geometrical isomers often show different physical and chemical properties. The difference in their physical property is more significant when there is more difference in their polarity. Usually, the dipole moment of cis isomer is greater than that of trans isomer, and hence the cis isomer usually have more solubility in polar solvent. In general, the trans isomer are more stable than cis isomer.